Today we're going to look at learning target 4A, which is how to identify a linear function. For this learning target, we're going to be looking specifically at graphs, tables, and equations. Before we get into identifying whether something is linear or not, let's first look at a definition. A linear function can be represented by a straight line on a graph, has a constant rate of change when you're looking at a table, and has all variables to the first power and are not being multiplied or divided together in an equation. Those are three simple ways to quickly tell whether a function is linear or not. Let's start by looking at graphs. In this case, we look at the line, and since it's going at a constant rate of change, it's straight throughout the entire graph, that means it would be linear. Second graph is also linear because there is a constant rate of change. Does not matter whether the line is moving up from left to right or down from left to right, as long as it is a constant rate of change and is straight throughout the entire graph, then it would be linear. In this situation, this is not linear. Although it has two pieces that are straight, the fact that it does not continue throughout the entire graph as straight means that it is not linear. This would be an example of a piecewise graph. Let's now look at tables. Whenever you're looking at a table, you're looking for a constant rate of change. Start by looking at your x values and make sure that those are going at a constant rate of change. In this case, our x values are each increasing by 1, which means we can then look at the y values and make sure they are going at a constant rate of change. In this case, each y value is increasing by 3, which means that it would be linear. Again, here's another table. Look at the x values, make sure they are changing at a constant rate. In this case, they're going up by 2, which makes it a constant rate of change. Then we have to look at our y values, which are decreasing by 2. Since they both have that constant rate of change, that means that it is linear. In this table, we again look at our x values. Now notice, the x values are not going at a constant rate of change. Here it increases by 1, then increases by 2, then increases by 2 again, and increases by 1. So what we need to do is we need to look at the average rate of change with our y's. When there's a difference of 1, the y's are increasing by 2. Here, where there's an increase by 2 on the x values, our y's increase by 4. Now 4 divided by 2 gives us the answer of 2, which means that if I were to put a negative 1 in here for x, this would be 9, which would continue that same constant rate of change. Same thing when I look at this jump of 2. If I were to put a 1 value in here, since this jumps by 4, if I were to divide that by 2, I can see that at each step it is still increasing by 2. So this is a linear situation. Let's now look at graphs. Remember, in order for something to be linear when you're looking at a graph, all the variables need to be to the first power, and the variables cannot be multiplied or divided by each other. In this case, both the y and the x are to the first power. They're not being multiplied by each other, so therefore this is a linear situation. Looking at this second one, we've got our variables, y and x. This one is somewhat tricky. Since these are both in parentheses, we would have to use the distributive property in order to simplify it. If I use that first step of doing x times x, that would give me an x squared. Since that is not to the first power, that eliminates this from being a linear function. So this is not linear. This would actually be quadratic, which we will learn about later in the year. Looking at one more equation, again, we would want to simplify this. If we were to distribute here, we would get 2/3 x, which again is still to the first power. The x and y are not being multiplied or divided by each other, so therefore this is a linear situation. Remember, the main focus of this learning target is simply identifying a linear function. Most linear functions will be written in one of these following three forms. And you'll learn more about these as the unit goes on. We'll be using all three of these to learn more about linear functions. But on the far left in the red is slope-intercept form. That's the one that most of you are pretty familiar with based on your learning in 7th and 8th grade. The one in the middle, point-slope form, is another form that we will learn about. And then on the far right is standard form. All three of these forms can be used interchangeably, and you may see linear functions written in other formats, so as long as you remember those two rules, that the x and y must be to the first power and cannot be multiplied or divided by each other, you should be able to tell whether something is linear or not by looking at the equation. But again, these three forms are the most common forms that you will see linear equations written in. Make sure you get Cornell notes on this and come to class with any questions you may have.